So far, we've talked about a system of equations that has one solution, one pair of values that makes both solutions true. So this first example is going to be one of those systems of equations, one where the two lines will intersect, and that one point where they intersect will be where we find the two values, the x and y value, that make both of these equations true. As a reminder, you always want to put both of these in slope-intercept formula, so y equals mx plus b. Here's our slope, here's our y-intercept. We can see this first equation is already in slope-intercept formula, y equals mx plus b. However, this second equation is not. So I'm going to go ahead and rearrange it, not change anything. I'm not going to double anything, or I'm not going to sort of change what the equation itself means. I'm simply going to rearrange things so that it's in this format. So we know that I need the y on the left side, and this 2 here needs to join the x over on the right side. So I'm going to subtract 2. Here the point was to cancel out. Over here the point is because we do need things to remain balanced when we're rearranging those equations. So over here I'm left with negative 2y, and on this side I've got 2x minus 2. However, y is still not isolated, so I'm going to divide by the coefficient, which is negative 2. Whatever I do to one side, I do the other. So I'm left with 1y equals 2x divided by negative 2. So 2 divided by 2 is 1. My signs are different, positive and negative, so that's going to be negative 1x, or just negative x. Negative 2 divided by negative 2 is positive 1. So here is my new equation. Means the same thing as this equation, it's just written in slope-intercept formula. And to graph them, I first need my y-intercept, so this is positive 2. So I'm going to assume each of these little blocks counts as one unit. So this would be where the positive 2 was on the y-intercept, on the y-axis. And then I've got 1/3 x, so this is positive, so my slope is going to increase. And remember that it is rise over run. So I'm going to rise 1 in the positive direction and run 3 in the positive direction. So up 1 over 1, 2, 3. Up 1 over 1, 2, 3. And to go in the opposite direction, I am going to go down 1 and over 3 in the opposite direction, because I'd be going in the negative direction for both of those. And a negative divided by negative still keeps this as a positive. And we know we need to end up with a straight line. So down 1 over 3, down 1 over 3. Now, I drew these boxes by hand, so it's not going to be perfectly even, perfectly straight, but should be good enough to help us understand what we're doing there. Now, I've got this second equation, y equals negative x plus 1. So it starts at positive 1. It's my y-intercept. It's a negative slope, so that means it's going to decrease. And it says negative x. It's the same as negative 1x, so that's going to be negative 1 over 1. So down 1 over 1, down 1 over 1. And if you're unsure, because I know some of you are like, well, do I go in the negative direction for the rise or the negative direction for the run? Well, this says negative x, so we know that this is the direction the line should go. It should be in a decreasing. All right, going in the opposite direction, up 1 and over 1. And since these are two linear equations, I have two straight lines that I'm representing on this graph, and they intersect in one place. And whatever happens to be, that would be the solution that would make both of these equations true at the same time. And we're not worrying about finding the solution right now. I just want you to know that right here it tells us there's one solution because there's one place where they intersect. Remember, these lines would technically, if we're not given constraints, go on in either direction forever, and that is the one place where they intersect. Now, it's not always going to be the case that lines will intersect in just one place, or that they might intersect at all. So in fact, there are 3 possible numbers of solutions. One, where they intersect once, and then we're going to have an example of when the lines are parallel and they intersect not at all, 0 times, and we're going to have an example of where the lines are essentially the same line, they overlap completely, and it's a terrible infinity sign. There we go. There's technically an infinite amount of options. So let's make sure we understand what's going on there. So this is already written in, the first one's written in slope-intercept formula. The second one is not, but luckily, looks like that one is an easy fix because I've already got a single y. So I'm simply going to add 2x to both sides. I've got y on this side. Just to keep things nice and neat, I'm going to keep this 2x first, and it's positive 2x plus 2. So this should be y equals 2x plus 2. So if I graph this first line, my y-intercept's -1. It's a positive slope, and it's 2, so that's the same as saying 2 over 1. So I'm going to rise 2, go over 1. Rise 2, go over 1. Rise 2, go over 1. Opposite direction, down 2, 1 the opposite direction. Down 2, 1 the opposite direction. So I should have a nice straight line. Again, it looks a little curved, but that's just because of my drawing of this. The graph, the grid. All right, second one here. So my y-intercept is 2. So it's actually going to go here. But my slope is the same. See, both instances the slope is positive 2. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, and so on. Now, again, just remember, it's not going to look perfectly straight. That's just because I hand drew the grid. But we can see that these lines are going to be parallel. So remember, parallel lines, they're next to each other, but they never meet. They never intersect. So there is no solution where both of these will be true. Because these lines are parallel, they never intersect. So what you should have noticed here is one of the big things that is going on is that the slope is the same, but the y-intercept is different. In our first example where there is one intersection, our slope was different, and in this particular instance, our y-intercept was different. You can actually imagine it wouldn't matter if the y-intercept was the same or different for this one. For example, if I had lines connect here on this y-intercept here, they would have the same y-intercept but different slopes. So what really matters for this when there's one solution is that the slopes are different. Down here, for parallel lines, the slopes are the same, but the y-intercepts are different. See if you can figure out what's going to go on for this last one where they overlap. So again, I've got this first equation written in slope-intercept form. I want this second equation to be written in slope-intercept form. So I'm actually, because I'm running out of room, I'm just going to solve it from this equation here. I want this y isolated, so first I'm going to subtract 2x from both sides. I'm left with 4y on this side. I just want to keep my x first to keep that pattern of y equals mx plus b. So that's a negative 2x. This is a positive 20. I want to divide by the coefficient, so that cancels out, and I'm left with just 1y. So I have y equals 2 divided by 4 is negative 1/2, because it's a negative there. Negative 1/2 x plus 20 divided by 4 is 5. Notice, when put in slope-intercept formula, this equation and this equation are exactly the same. So my y-intercept, 1, 2, 3, 4, 5. My slope is negative, so it's going to decrease 1 and then over 2, decrease 1 then over 2, decrease 1 then over 2. Go the opposite way. up 1 but in the negative direction 2, up 1 but in the negative direction 2. And then if I were going to go ahead and graph the second equation, I would literally graph right over top of that equation. Let's try that again. So technically, all of the points of the first equation intersect with all of the points of the second equation. Right? Now notice here, same slope, same y-intercept. So you don't actually have to graph any of these to know how many possible solutions there are. You can follow along with this little chart here. 0 solutions means the lines are parallel, they have the same slope, but a different y-intercept. Remember, as long as they are in slope-intercept formula, y equals mx plus b. 1 solution, one set of values that makes both equations true, means there is a set of intersecting lines. And remember, we're only dealing with linear equations, so only straight lines at the moment, no curves, no absolute values, so no angles, anything, just straight lines. They have a different slope, and the y-intercept doesn't matter. If there are an infinite number of solutions, the lines are completely overlapping. Essentially, they're the same line, and that says they have the same slope and the same y-intercept. So what I want you to do is I want you to pause the video for a moment and see if you can figure out how many solutions there are to each of these 3. So take out a piece of paper, put them in slope-intercept form, and see if you can figure out how many solutions there are based on this. And then come back and find the solution. Okay. By this point, you should have tried to answer this on your own, how many solutions do each of these systems of equations have, and you should be checking your work now. Now, I want them all in systems. I want them all in slope-intercept formula, so I'm going to quickly rewrite them. I'm not going to show you all the steps. I might show you just part of them, so this I know would be negative y equals 17 minus 3x, which is going to equal positive y equals positive 3x minus 17. If I rewrite this one over here, I've got 4y equals negative x plus 10, which is the same as saying 1y equals negative 1/4 x plus 10 over 4. This is what it should be in slope-intercept formula. My y-intercept is not the same. My slope is not the same, so I know there will be one solution. Second problem, they're already put in slope-intercept formula. Right away I can see the slopes are the same. The y-intercepts are not. So same slope, different y-intercept. This is telling me these will be parallel lines, and there are 0 possible solutions. These will never be true at the same time. Last one. All right, if I look at this, first step, negative 3y equals negative 9x minus 6. Divide everything by negative 3. That gives me y equals negative 9 divided by negative 3 is 3x, and then plus 2. This one here, I'm going to divide everything by 5, which gives me y equals 15 divided by 5 is 3x. 10 divided by 5 is 2. My slope is the same. My y-intercept is the same. Look up here, same slope, same y-intercept. They're going to be overlapping. They're going to be the same lines. So they will have potentially infinite number of solutions.